Hello everybody, my name is Fabian Delpi and together with my Brit Pedersen-Zari, we worked on ecosystem services assessment tools for regenerative urban design in Oceania. So as you know, there are global environmental challenges like climate change and biodiversity loss that require collaboration between disciplines to elaborate adaptation and mitigation strategies. And it is important that urban designers and ecologists work together to shift towards regenerative practices, which means that cities must be considered not only as isolated social economical systems, but embedded within their natural environment and contributing to its renewal. So there are several nature-inclusive practices that are in line with this regenerative paradigm, such as ecosystem-based adaptation. They aim to increase ecosystems and communities' resilience to the impact of climate change through development strategies that support natural ecosystems. They are gaining recognition among urban designers, and they are most relevant to the unique environments of Pacific Oceania Islands and Aotearoa, New Zealand. Currently, such projects are being implemented in Oceania, for instance, through the Pacific Ecosystem-Based Adaptation to Climate Change Program, in short PBAC, and the methodologies for implementing urban ecosystem-based adaptation in a small island developing nation context have been proposed, as illustrated here with the work of Pedersen-Zari et al. So as you can see, ecosystem-based adaptation practices require some ecology knowledge and rely on the concept of ecosystem services, which can be defined as the benefits that humans derive either directly or indirectly from the functions of ecosystems. And there are different categories, supporting, regulating, provisioning, and cultural, with some examples relevant to urban context here, such as habitat provision, urban cooling, water provision, and recreation. So it is difficult for designers of the built environment to integrate these ecological concepts in their projects because they lack the expertise. And there are many tools that could help them to assess and model ecosystem services, but it's difficult to choose the tool that is best suited. And moreover, some of the tools are not suitable for assessing ecosystem services in cities, and some are even restricted to specific geographical region or specific decision-making context. So there is a need to determine which ecosystem services assessment tools are best suited to designers in cities of Oceania. And it is important to facilitate the selection process because it will enable designers to integrate ecological values in their projects. So this research reviews the landscape of ecosystem services assessment tools and evaluates them for their applicability to cities and towns in Oceania. And the theoretical review is further complemented by a pilot study of one tool that is applied in the urban context of Wellington in New Zealand. So I will describe briefly my methods. So first, an extensive list of ecosystem services assessment tools was drawn up through an investigation of ecosystem services related database, tools, official websites, as well as using the scientific search engine Google Scholar. Then the list of tools was refined through a first set of criteria to ensure that the tools were accessible by designers and applicable in Oceania. Then a second set of criteria was applied to ensure that the tools were suitable for urban application in cities or towns. And finally, the selected tools were classified and evaluated based on different case studies, most of them that were collected in the literature review, and one conducted as part of the research in Wellington City. So from the initial list of 95 tools that was collected in the screening, 4 tools are judged to be relevant to the research context. So these tools are Costing Nature, Lucy, Invest, and RES. And Lucy is the one that was tested in the pilot study in Wellington City during this research. So I will not describe them individually here because that's available in my reports in much detail, but I will make a relative comparison. So the 4 tools allow biophysical quantification of ecosystem services in most regions of the world, and they provide specially explicit outputs that are really useful in urban design. However, they differ in terms of technical characteristics, such as the scale and resolution at which they operate, and they have different functionalities and require different time and money investment. So in my report, you can find some tables that detail these tools' characteristics, such as the typical context of application or the finest resolution, the type of outputs that are delivered, and I also specify the different ecosystem services that each tool assess and model. So I invite you to explore these tables in my report. Here I will briefly illustrate the type of outputs that you can expect from these tools. Here it's the flood mitigation ecosystem service that was assessed in the Lucy pilot study conducted in Wellington City. So it's just to illustrate some of the outputs that are delivered, but I will not give every type of output in this presentation. So from my results, it comes out that the 4 tools are suitable for urban design projects in Oceania. However, the tools evaluation reveals that urban designers or even architects must consider several factors when they choose a tool. For instance, the time and resource available, as well as the scale of their project. Moreover, the commitment to learn the tool as a new professional skill is relevant because designers must be inclined to develop their skills that will make them able to integrate ecology in their future project. As well as the expectation in terms of outputs, precision and reliability is quite important to consider. And finally, I would emphasize this point because some tools will take a lot of time when they are first applied in a given context, but once the tool has been tested in a situation and the input data have been collected, then the parameterization of the model is much more easy and happens quicker. So from the tool evaluation, I have proposed 3 orders of complexity of application. So costing nature is the simplest one to use, and Lucy and Invest are considered intermediate options, and RES is the most complex one to use. However, they differ in terms of support that is provided by the developers to the users, and that's also something that has to be considered when choosing the tool. The pilot study of Lucy in Wellington City supported the notion that ecosystem services assessment tools provide information that are usually not available to designers, and the integration of such information early in the design process can lead to new design thinking as well as facilitate the collaboration with ecology experts in a later stage of the project, which is very important for multidisciplinary work that is required in ecosystem-based adaptation projects. So to conclude, these tools, Costing Nature, Lucy, Invest, and RES, are available to designers and they can be applied in cities of Aotearoa, New Zealand, and Pacific Oceania Islands. And their application will facilitate the integration of ecology in urban design, as well as the collaboration between designers and ecology experts, which is beneficial for regenerative design practices such as ecosystem-based adaptation. And finally, I would like to say that I invite you to explore the tool's website because some are expressing rising interest in urban application, such as Lucy and Invest. Invest already has developed models for urban context, and it's important to know that the tools are under continuous development to facilitate their application and add new functionalities. So if you have any questions, don't hesitate to contact us. Thank you very much.